won't introduce myself too much. The most important thing for you to know is that I've spent a lot of time writing code where I'm maintaining other people's code. A lot of that code was legacy code, and some of it was quite bad. If you want to find out more about who I am, I have a website, so I don't have to tell you. I have a Twitter account, and you'll make me super happy if you all follow me. Until tomorrow when you unfollow me again. I'd like to start with a story of back when I was a young developer in the late 90s. So when I was younger than pretty much all of you. I was in my first year out of university, and I was working in Cambridge in England for a large IT consultancy. And I'd started a 12-month assignment working at a customer location on a software maintenance team. The maintenance project was to maintain an asset management system for the water company. And the assignment was 12 months because it took several months to understand the system. This was the 90s, so this system had been built on a classic waterfall software development with everything that involves the upfront design, the documentation, the testing. And amazingly, perhaps, what sometimes happened, and it happened on this project, the project was delivered on time and on budget. 2 years later, I joined the maintenance team. So picture it, there's 5 of us sitting not sitting around a table, but like sitting around a table in a smallish cubicle in some office near Cambridge in England. And we're maintaining this software system. Now, it was tricky to maintain because there were all of these proprietary technologies, nothing standard, nothing open source. It was a GIS system, a geographic information system with a design program. It ran on Windows NT 351. That's the one that came out just before Windows 95. And it had custom video cards so you could run 2 monitors for the mapping part of the software. The code that we were maintaining and the code where I was fixing bugs and improving things included 2 proprietary languages that nobody has ever heard of. The more scary of these 2 languages was a kind of superset of C associated with this CAD program called MicroStation. So this was largely incomprehensible, so we wrote most of the code in this other language whose name I can barely even remember. Anyway, so this is the scenario. We have this complex system, all of this proprietary technology. The project was delivered successfully using waterfall development. And so what that meant was the thing that I still remember that really impressed me. Above my desk was this shelf. And on this shelf were these bound A4-size volumes of documentation. I think the functional requirement specification was about 6 volumes. And the technical specification was about 12 volumes, 10 maybe. I think the whole thing was maybe a half a meter of shelf space. It was impressive, and we never read it. So I didn't really think about this much at the time because I was an impressionable young developer, and that was normal at the time, but it turns out that was not normal. Why didn't I need to read the documentation? Well, it turns out that the project was very well managed. So this is not a coincidence. It had been delivered on time. And there was a very careful rotation of people on the team. So the careful project that produced all of this beautiful documentation and delivered the project on time also resulted in a support team where we maintained the software by joining the team for 12 months and taking it in turns and spending several months learning to understand anything at all about this system. But the technical documentation, it was still there. And there was a time when I did use it. So the impressive thing about the maintenance project was that it was very careful. There were very few bugs. We modified the code very, very carefully. So we did code review, and we did code review in this kind of extreme way where all production code was reviewed in a code review meeting once per week. We would sit around a table like one of these, and all of the production changes for that week were printed on paper. And we would all go through this with a highlighter pen. Like, I'm serious, I'm not kidding. This really happened. We would go through this with a highlighter pen. Everybody had prepared for this meeting by looking at the changes for that week. We would discuss them. And as a result, there were pretty much no bugs. This was very reliable software. But occasionally there were bugs because, we were third line support for maintaining this application, and any bugs that were discovered, we fixed. And so I remember one particularly challenging bug, possibly the weirdest investigation I ever did as a programmer. The printing didn't work. Now, this is the initial bug report, right? Customer, user, bug report, printing doesn't work. I mean, that could mean almost anything. So the first part of the investigation, figuring out, what do you mean it doesn't work? So there was one particular map. So remember, it's an asset management system for the water company. The assets are the water pipes, the sewers, this kind of material under the ground. And they would print large maps on this sort of A0 plotter, the thing with paper like this wide. And one of the maps would not print. So I have to fix this. It cost me about a week to figure out what was going on. The first thing I had to do was to figure out how printing even was supposed to work. And so this is the point when all of this documentation on the shelf was great, because there was the module subsystem specification for the printing system. So I would have read that, figured out how printing worked, because I didn't want to ask my colleagues, how does printing work? And expect them to kind of lecture me all day. Neither of us wanted that. And eventually, this took me a week, so I'm going to speed up a bit. But eventually I figured out what the problem was. It was an off by one error. It was an off by one error in the code that printed the list of assets next to the map. And sometimes, if there were many of these things, they would need to be printed on the second page. And the code was confused about whether or not a second page was needed. So it needed a second page, but it didn't need a second page, and printing failed. How did you reproduce this bug? There was one particular map. And so it turned out that this bug would appear if an area in the east of England, measuring 1,000 meters wide by east to west, by 500 meters north to south, if that area contained precisely 49 manhole covers, the map would not print. I'm telling you this story because what I learned from this project is that almost all of the time we didn't need any documentation, but it was there if we did. And that week, I needed the documentation. There's a catch to this project. So how come it was successful? How come it was reliable? How come we maintained it? The answer is that it was phenomenally expensive, eye-wateringly expensive. If I adjust for inflation, because this was in the 90s, the initial development took a couple of years, 2 or 3 years, cost around 20 million euro. And 5 of us sitting doing this maintenance, I estimate in today's money about 1.5 million euro per year. So I'm not suggesting that we go and do this waterfall development. Like, nobody does this anymore. But it does make me think about the extreme example of documentation, because I've never seen this since. Extensive documentation on a project. A later project I worked on, now in about 2006, was a different scenario. In 2006, I was working for a small IT consultancy in Rotterdam in the Netherlands, famous for having a big port, big one of those. And we were working on a logistics system, and we had some expertise in supply chain management. And my employer, in one of the more strange deals, had acquired another company. The other company had some software, they had some contacts, we were going to do this project for one of their customers. So this is when I got hundreds of thousands of lines of somebody else's code. And it was bad. It was very bad. Everything imaginable was wrong with this code. So I don't want to scare you by going into those details, but we had to figure out how this worked. So ordinarily, you would look at the code and then you think, I don't understand it, so you'd look at the documentation. Guess what? No documentation. None at all. No access to the original developers. We just had to figure it out by, what can you do? You start at the user interface. I mean, when you eventually get it running, you start at the user interface, you follow the entry points into the code, you sort of navigate. I mean, there was a technique for reading other people's code. But because the code was bad, I would have accepted any documentation at all. Anything would have been better than no documentation. So this was the other extreme of a software maintenance project. So we did what we could. We figured out just enough to get the software running. We took on a very risky 6-month project to deliver it for a government customer. And we made some changes and made it look a little bit different. And 6 months later, we delivered this project. Now, we decided that this code was beyond saving. So this was the other kind of legacy code. So there's more than one kind of legacy code. And this is the kind of legacy code which is also known as other people's code. So obviously, none of us write that ourselves. Like none of you write bad code. But look at somebody else on the table you're sitting at. Do you trust the code that they write? So this is not an uncommon problem. Ironically, we got away with it in the sense that after 6 months, we delivered the software, and this government customer was going to run it on a secret network that we weren't really supposed to know about. And so we never discovered if they even put it in production because that would have been classified. Good news, we never had to maintain it. So we got away with minimum documentation. The only documentation we wrote was a better architecture documentation that looks nice to give to the customer to persuade them that there was some documentation. I don't think anybody read that. And some very detailed installation instructions. So this was the other extreme, no documentation at all and getting away with it. Now, if we'd seriously planned to maintain that software for another 5 years, I would have simply quit my job and gone to work somewhere else, because some kinds of code you don't want to see, especially when there's no documentation. And supply chain as a domain is interesting because it's quite complex. So, other people's code is bad enough, but other people's complex code, that's always worse. Fast forward a few more years, 2012, it was time to do it properly. We were going to write a new system, and we were going to make it maintainable. And this was my goal then, and this is my goal now, is to think about what is maintainable. How do we do that? So it's not really about documentation, that's just part of the story. So we had this situation where we'd been maintaining this warehouse management system for 10 years for a big global logistics provider. And this system was managing shipments and stuff going in and out of a warehouse like this one. And the code was pretty good, it was well maintained, it was cleanly written, there was some documentation. The problem was it was all written in Perl. And, I mean, Perl's nice, but at that point, most of the company didn't want to write Perl anymore. And I think we're down to the last 2 people who were willing to admit, that they still knew how to write Perl code. And so this is obviously a problem. We have a bus factor of 2. 2 people before the whole thing is just unmaintainable. But we were making a lot of money out of maintaining this system. So we reached a very dangerous conclusion, which is that we had to rewrite the system. If you ever think you have to rewrite a system, don't do that. Right? It's a terrible idea. Joel Spolsky in particular has written some great explanations of why it is a terrible idea. Rewriting something is a last resort. Because although we had legacy code, we had the kind of good kind of legacy code. It had more than 10 years worth of business rules and bug fixes and understanding. And so you might think you could reproduce that quickly, but it would take you another 10 years to fix all of the bugs and make it really work. And we went ahead anyway. Our strategy was to replace small parts at a time. It had electronic message interfaces, so we would replace the code for one message type at a time. We extracted services, microservices for administration, for identity management. So mini projects that were feasible, that we could finish in a short amount of time. And in the end, we also started replacing the main user interface by making a new user interface with a better user experience, and we would sort of compete with the old user interface. So once we had the initial release, we gave the users of the software both, and we kept kind of improving the new one until they stopped using the old one. And we wrote some documentation, but we'd had a lot of discussions about how to do this. And so in the end, we wrote hardly any documentation, but we wrote two particular kinds in some detail. We wrote all of the documentation you need on the first day of the project to get started, the documentation to install the software and to troubleshoot things in operations, the things that everybody would need to know, very practical instructions. And the other thing we documented was the data model, the data dictionary, the domain language, what in domain-driven design is called the ubiquitous vocabulary. We did this because in supply chain there's lots of jargon. It's basically a foreign language. You know, when people say shipment and journey and consignment and order, they mean really specific things. We had to learn how to use those. And this worked pretty well. We're very happy with the result of doing this. So these are, I worked on many, many different projects. These are 3 out of 40 plus over the course of lots of consulting and different companies. But these 3 projects had very different kinds of documentation. So what's going on? The first thing is that there were 3 different kinds of legacy code. There's the kind where the code is good, but it's all kinds of proprietary technology, so it's just hard to learn how to do anything. That's less common these days, but it's still a common problem. Then we had the other bad kind of legacy code where it's just bad. It's just written by other people who are bad people. You know, ideally we try to be adults, and be respectful of other people's choices, but sometimes you see code and you think, whoever wrote this is a bad person. That was the second project. Fortunately, we never met. I guess that would have been bad. And the third kind, as I said, is the good kind that encapsulates all kinds of knowledge. And this is the kind you should never rewrite because you're extremely likely to fail and kill the company. High risk. Best plan is to not do that. But we had this extreme situation. So I've got another, I like 3s. So we've got another 3, which is there are 3 kinds of documentation. So the first kind is like this mythological fantasy of extensive documentation. And it turned out that it was really about the process and the management and the huge amount of money spent on software maintenance. The documentation itself, that was just a side effect of waterfall development. No documentation is always bad. Unless, I suppose, the code is absolutely perfect. But this was not the case. And the third kind was, just code where we deliberately planned for maintainability. And I think we did a bit better. I wasn't working there 10 years later. That's in 2 years' time. But I started to realize over the course of all of these kinds of projects that actually you can make software more maintainable. You can deal with unmaintainable legacy code. And part of how you do that is a sensible approach to documentation. There are 2 really bad approaches to documentation, which are also here. The first really bad approach is extensive documentation, because nobody can afford this. It's amazing that it ever happened. And the second really bad approach is none at all. So the rest of this talk is about what's in the middle, what's in between no documentation and too much, or extensive. So I learned that, when you have unlimited money and you have too much documentation, it's a kind of a backup. So that's not such a bad thing. Not having a backup can be a problem. And that when you're planning for maintainability and you do actually have some kind of constraints on how much you can spend or how much time, then really quite a small amount is a good amount. And there are two big constraints on how much documentation you can afford. I mean, one is simply that it takes time, and the other is, of course, is that it's not such a popular thing. So just to check that you're all still awake, it's time for a show of hands. So you're all C++ programmers, except for me, so I didn't mention that, but it doesn't really matter. Put your hand up if you've written any documentation at all in the last 12 months, in the last year. Who's written some? Okay. Not everybody. Some of you are asleep or not admitting to it in public. Keep your hand up if you liked it. Yeah. So this difference is the documentation problem. And that's maybe a bigger constraint. Nobody wants to do this. At least none of us. No programmers. So what does this teach us? In thinking about this, in trying to work out whether we can improve on this situation, there are some lessons learned. So to recap, there are various reasons why we don't like documentation that other people have written. There's usually something wrong with it. There's usually all of these things wrong with it. I mean, it's either missing completely or it's just wrong, we don't trust it. We rarely trust documentation. We normally have healthy suspicion that it's lying to us and we should just look at the code. Okay? And you may be right. Now, why would that happen? The main reason that happens is there's too much. But sometimes it's just missing because everybody was hoping that somebody else would do it. Alan Kelly in the UK explained this by saying that there's no documentation fairy. There's no mythical creature who, in the night, will magically document the code you've been writing. I mean, it would be nice. We would all love this to be true, but it is not true. There is no documentation fairy who's going to write your code. And so what this means in terms of agile software development is that documentation is just another deliverable. If you want it, you have to spend time on it and therefore pay for it and prioritize it and make it happen. You should only do so if you need it, if it has the same kind of value, if it's important enough. It's not for free anymore. It wasn't for free back in the waterfall days either, but it was just hidden in the enormous cost of those projects. So if you actually have to pay for everything, you have to decide to pay for it. And if you don't, no documentation. The Scrum Guide, for example, does not say don't write any documentation. In fact, I don't think it even uses the word documentation once. But if you want it, you've got to spend time. It's not free because it's of the opportunity cost. If you're writing documentation, you're not doing other work. And writing it's not even the worst part. Reading documentation takes a lot more time. So that can be even more expensive if you get it wrong, if you have too much. The only thing worse than 10 pages is 1,000 pages. Where do you even start, right? You never want to find 1,000-page documents. I mentioned that in the waterfall development we had technical specifications. That was let's say, the old-fashioned kind of technical documentation. Technical specifications were part of this upfront design. Now, waterfall development is responsible for many bad ideas that we're pretty much free of now. But one of them is that there was a separation between design and maintenance. These are just both software development. But the documentation that we used to have, these specifications, these were not even that helpful when it came to maintaining the code, because this was how somebody thought they were going to build the system, which was usually not entirely true. And when you want to maintain some software, you need a different kind of documentation. So it's not even that we should add the specifications that were the thing in the past. We need different kinds of documentation because we have a different purpose. So technical specifications align a team on how we're going to build the thing we're going to build. It's a kind of shared understanding of the design. But if you want to maintain something, you need to understand how to modify the code. So what is it that produces that? I'm going to shift track now and go back to legacy systems. And I had to invent a word for the next slide. The problem with some legacy systems, the problem with badly designed things, is that they are very hard to document. Worst case, your system is undocumentable. A bad design kind of often reveals itself when you try to explain it. The same goes for user interface design. One way to discover your user interface design is bad is that it's very hard to write the user guide. If you're a writer of user documentation, it's a test. It's like, how hard would this be to explain to somebody? Anyway, so I needed that to explain the rules that I discovered so far. So 3 rules. I've said all this before. The bad code needs whatever you can get. But you can't document all of the code because there's always too much code. The amount of code we have in old systems, legacy systems, can be huge. If you're lucky, it's only 100,000. If you're unlucky, it's millions. We can't really conceive of how much that is, but you'll never read it in your lifetime. You just kind of look at little bits and try and fix the bugs. And sometimes you just have to give up on some legacy system because it's undocumentable. That's why I had to invent the word. So I think looking forward, I want to be more positive than that. I want to give you some advice that you can use. Now, we've established that none of you like writing documentation. So I think the most useful thing I can do is tell you how to cheat. Cheating, and I mean cheating in a positive, constructive sense, in the sense of constructive laziness. So constructive laziness is thinking of a clever way to do less work, often by writing code. But maybe not in this case. So the good kind of laziness. So let's consider, what are your options if you want to not write documentation? Or you want to write less? I want to start with, I want to establish a boundary. What are you willing to do? To write 0 documentation? In a way, it's quite easy. All you have to do is just put your mobile phone number in the code, and you'll be on call for the rest of your life. But you won't have to write any documentation because you can just answer the phone and explain all of these questions. Now, if this is a good solution for you, we're done and you can go and get some coffee. I've never really wanted to do this myself, partly because I hate phone calls and partly because this just doesn't seem like a good long-term plan. So this is where we get to more sensible advice. So just to be clear, I absolutely agree with everybody else who realizes, well, you shouldn't document bad code, you should just write good code. Absolutely. No, this is true. Right? No irony. Make the code better, as good as possible, because the better you make the code, the less documentation is required. But here is also the problem. Maybe you don't need any documentation, or at least not very much, if your code is perfect. And again, think about your own perfect code, and then look at other people in the room. And be honest with yourself that sometimes it's Monday morning and it's been a tough weekend and you're not really writing your best code right now. That code is there as well. So write the best code you can, because your reward for writing better code is fewer comments. How do you achieve this? That's largely what the topic of clean code is about. There are more things you can do for specific kinds of documentation. So one of the kinds of documentation that we used to have to write a lot more of was installation instructions. But you can automate all of that. And what we all love doing more than writing documentation is writing code. So in a way, the whole purpose of DevOps is to turn a documentation problem into a coding problem, and everybody is happier. Even if it takes 10 times longer, we're still happier. And that's generally a good thing. Very good thing. And there are some other ideas, like you don't have to document things that don't need explaining. You don't need to explain things that everybody recognizes. So an old example in object-oriented programming is the notion of design patterns. You know, if you choose the correct name for your class, then people will get the idea that they know how this works, and you won't have to explain it. That is extremely powerful. And so you can use that at lots of different scales. Make the code or the module or the whole architecture recognizable in some way that reduces the amount of documentation necessary. And this turns out to be, these are examples of the overall strategy. Find ways to make the documentation less necessary. Find ways, individual ways, to chip away at the amount of documentation you need, if you're honest, and not need as much. I've added this slide this morning because I was having a conversation last night with Klaus here about how one of the things developers will do to avoid writing documentation is to start building software to manage the documentation. So my theory is that all of the wikis in existence exist because somebody needed to write some documentation, and they said, now I need a documentation system. I'm going to implement a wiki from scratch. And now they've not solved the documentation with coding, they've avoided the documentation problem with coding. Right, they're working on something else. So I'd just like to focus on solving the documentation problem instead of avoiding it and getting distracted by tools. I have no tools for you. I have no tools for you today at all. Here's why. What is the ideal, the perfect documentation system? It's the one that works for you as a programmer. It's the one that is integrated with the code, and it lets you just type the documentation in the same place you type your code, and there's version control, and there's all of the good things you want. And in particular, you don't spend 6 months implementing yet another wiki. Any suggestions for what I'm talking about? I'm not sure if this is a surprise. So this is built into every programming language. It's called code comments. Yes, I'm going there. I'm going to talk about code comments. I apologize because I know this is a touchy subject. It's almost a taboo among programmers. Like, don't ever mention comments. You know, this is in the secret handbook of advice to conference presentations. You know, never mention code comments. It's after lunch, you might be a bit sleepy. I feel I need to shock you. And so let's try that. Indeed, we don't really talk about it, but, and in fact, indeed, so I've experimented with trolling developers many times by suggesting that maybe you should write code comments. And developers are amazingly creative when it comes to reasons why they do not need to write comments. I've heard everything. I really have heard everything. And if you try me at the Ask the Speakers session after this, I have a counter-argument. I can win this argument because I've done it more times than you. Mostly, you're just making excuses. And here's the thing. Comments are, in some ways, the ideal documentation system. The only viable alternative to no comments is no technical documentation at all, because this is the easiest kind there is. It is the easiest thing to do a small amount of comments, small amount of documentation. And here I mean specifically documentation for other programmers. So not documentation for people who don't see the code. It has all the advantages. It's right there in the code. If you can't maintain the comments, which is a frequent objection, they're out of date because somehow I can't maintain them, then you're not going to be able to maintain any other kind of documentation. The wiki page, the Word document, whatever else it is you have. Comments are the easy thing. You know, version control is right there. They're probably on the screen when you're looking at code, unless you do that trick of setting the comment color in your syntax highlighting to white text on a white background. Please don't do that. Don't do that. Don't do that. Comments are not the enemy, right? I mean, meetings are the enemy. Because if you opt to try and not write documentation or even comments, and you haven't put your phone number in the source code, guess what happens? You will be invited to a lot of meetings. And I've tried coding in meetings, but it's not popular. It tends to be mentioned in your performance review at the end of the year. So don't do that. Don't do that. And the thing is that comments, they're not that scary. So here is just as a thought experiment, here's how to write comments and make them be good. Start off by writing good code instead. Do the best you can. If your code is perfect, your reward is you might not need a comment. But then you need to write a comment. Now, how much am I asking for? Right, what is my ask? I'm asking you to spend about 10 minutes per week on this. I'm asking you to write one sentence at the top of your class and leave it at that. and try and write a good sentence. This is the interesting part because it's an experiment. If you can write this sentence as fast as you can type, if you can write the short version of the document of the documentation comment, let's say in 30 seconds, it might be that the comment was not necessary because it was all quite obvious. But if after a few minutes you don't have a good comment, you've discovered something interesting, the code needs the comment. If it takes you more than a few minutes to understand this code, it needs the comment, so you should definitely write it and leave it there. If you need more than one sentence, then you've discovered more things, some kind of complexity or difficulty in the code that needs comments. And you need these so that you can then know what you're going to refactor, because the next step is to fix the problem in the code, if you can. But here's the catch. You don't necessarily have time to finish the refactoring today. So write the comment, and then do the refactoring, and then delete the comments that you no longer need. And you don't get to swap the order of these steps. You don't get to say, well, I'm going to refactor the code and then delete the comment, so I don't have to write the comment in the first place. This is cheating in the bad way. Because in the meantime, it might be 3 months, and then this code is still incomprehensible. Deleting comments is like deleting code. It's a happy thing. Deleting comments and deleting code is like deleting text in writing. If you're writing a novel, you're going to have to delete a lot of it before you're finished. Little known fact about writing. It's just like other kinds of writing. The other thing that's also true of other kinds of writing is that most of the work is rewriting, is editing things. Most of the coding is editing existing code, not writing new lines of code. So you have to enjoy this too. You have to successfully figure out how to improve it. And the rewriting lets you do all of this incrementally. You can do this in a small loop, in a few minutes. Add more things if they need explaining, but otherwise do a loop. If you do this consistently, you will end up with two things. You will end up with a short amount of documentation, 1 sentence per class, where that is enough. And where you've got longer comments, you know that you need to refactor until 1 sentence is enough. Best way to do that is usually make the class smaller. 500,000 lines of code in a class is probably not a good plan. I wonder how many of those were comments. Dread to think. And iterate this. Now, I'm talking about comments here, but this applies to all of the kinds of documentation. This iterative approach, spend a very small amount of time on it, try and go for the shortest amount you can get away with, and focus on improving the code. So this is just straight practical advice. And this is the part of clean coding that is often missed. But that's not all. I have time for some more tricks, techniques for writing less documentation. So this is roughly what you have to do if you're going to write the documentation yourself. But if in your career you start to get into management roles, you learn to discover the power of getting other people to do work for you. Sorry, delegation is a positive thing. This is a good thing to mention in your performance review at the end of the year. For example, one of the things I did a few years ago with 2 of my colleagues was co-write a book about a web framework. And all of the code is in Scala, not C++, but same difference. Eric and Francisco and I, we wrote this book so you don't have to. This is important because writing a book takes way too much time. If you're ever tempted to write a book, don't. You don't have time. You know, unless you're using it to avoid working on something else that you should be working on. Writing books, in fact, is the waterfall project of technical writing. It's the waterfall development project. This took 2 years, literally 2 years, start to finish. There's no good explanation for that. Writing a blog post that you can do in a few hours, and then doing another one, and then doing another one, that's the agile development of documentation and technical writing. But the reason I mention this, apart from obviously to show off, is that there's an interesting technique here. This represents OPD. OPD is other people's documentation. And so this is documentation that you did not have to write. This is a very powerful technique if you can learn to leverage this. This works on several levels. So There are lots of reasons to not like frameworks, but other people's documentation is what's going on here. That was about a web framework. But it also works at the line of code level. A dictionary, for example, and this one is literally installed on my computer and it's great. This is also other people's documentation. So this is about naming things. One of the, traditionally the hardest thing to do in your code, apart from cache invalidation, is to name things well. Sure, it's very hard, but your reward is that you get to delete comments if you come up with a good name for things. If you know that your name for your class or your method or whatever is not great, you need to write a comment to explain what you meant to say in the name, but you couldn't figure it out. The best way to get better at naming, and you can all get better at naming, by the way, is to learn more words. And that's where the dictionary helps you out, and especially the thesaurus, because the thesaurus is literally the other words that you can't remember. And it's hard work. There's no easy way. This is literally like learning a foreign language. And if you're writing code in English and that's not your native language, then it's literally learning a foreign language. But here's the thing. If you invent words like undocumentable earlier, which is not in the dictionary because I made it up for humor, if you invent words, then you have to explain them in comments or in data dictionaries or in a glossary for your project. Documentation. But if you choose a word that's in the dictionary, it already has documentation. Indeed. So this is a key secret of domain-driven design, is to not invent language, but to use the language that already exists. This is difficult, but it's very rewarding because you can avoid documentation. The more subtle version is when you're working in some weird domain like supply chain management that has all of this jargon that is not in the dictionary. Or rather, the words are in there, but the definition is wrong. It's not how it's being used by your customer. That's when you need to write the glossary for your project to explain the jargon, whether it's finance or banking or insurance or whatever. However, you maybe don't need to write those definitions. For example, Wikipedia pages tend to explain things that are other people's jargon. So there's lots of other kinds of documentation that's other people's documentation. Standards documentation, for example. Anyway, there's more. After all of that, you have to write some documentation. And so what I learned from my projects over the years, and what I implemented, is my next invented 3-letter acronym, which is minimum viable documentation. The correct amount of documentation for your project is not extensive, and it's not none, it's not 0. It is a tiny amount. It's what you write in 10 minutes per week. So code comments, roughly 1 sentence per class, is the first part of that. That explains the code probably as much as you need to. But it doesn't explain the system as a whole. There are things that it doesn't cover. Open source communities have taught us what is the other kind of documentation you need at a minimum. That is the README. Open source projects on GitHub have a Markdown file, which is the README. And they should contain these kind of topics. Now, bizarrely, most of them are not as good as they could be. It's not hard to come up with this list of useful things to put in your README. I've tried this. You set people down for 10 minutes. If I gave you 10 minutes without showing you this slide, you would be able to come up with this list. But if you never tried to do that, then you would only document one of these things. If you write 20 to 100 words on each one of these things, that is quite a lot of documentation. And for many projects, that's all you need. If you use the other techniques, then this kind of minimum is enough. Find the minimum that works. Find the minimum that prevents meetings. Sometimes your software is indeed more complex, and if you're lucky and if you've designed your system well, if your architecture is good, it will be complex in one place, in one way. When you have complexity, you need some additional kind of documentation. So in my supply chain example, the supply chain projects I worked on, it was the data model and the domain language that was complex. Everything else was not so bad. You could read the code, that was okay. But the language and the data model was nightmarish. So we needed the data dictionary. We needed the explanation of what the terms were, what example data looked like, what the validation rules were for the data. Didn't need to document anything else. And so in most cases, if minimum is not enough, you probably only need one more thing. And that's what these are examples of, what the one more thing might be to document that complexity. If there are lots of different things on your system that are complex and need documentation, then maybe you've learned a lesson about software architecture. The ultimate delegation move, if you're a manager or an aspiring manager, is to grow your empire and hire more people. These people are technical writers writing documentation. They like it. It turns out, for just about every kind of thing that you have to do, there is actually a role where people who like that thing do that thing. And they get really good at that thing. So for most of my career as a programmer, I'd never worked with technical writers. Working with a technical writer is a revelation, because not only do they like it, but they're better at it than you will ever be, probably. That's not a coincidence. These things are related. But think about it. Think about user interface design. We often have separate people doing that because they're good at it, because they're better, because they like it more. If you look around your development team and you see, the people who edit all of their code in Vim or Emacs, they're probably not the people you want designing your user interface. And everybody's happy with that. This is not, this is not a controversial statement. You designate one person to be the user interface designer, the graphic designer, and maybe everybody should understand it a bit, but you don't all need to be good at it. And the same is true with the writing. So I understand that on pretty much every team I worked on, I was the only programmer who liked writing documentation. This is my confession. I like writing documentation. And the rest of the team was generally pretty happy with that. Go figure. Okay, so to wrap up, just a few techniques that other people have talked about that are probably more useful when I share the slides, because there are links that you can click. The slides are on my Twitter account at the end of the presentation, auto-tweeted in 10 minutes. So it's not too late to follow me on Twitter and get that. Eric Holscher is the American founder of the Write the Docs community. It's a community of people who like writing documentation. They have their own conference called Write the Docs. I'm not kidding. This is advice for technical writers who maybe don't have a development background, but this mirrors what developers tend to do naturally. I've worked on several teams that have reinvented the idea that we should treat all of the documentation as if it were code and use all of the same tools, the same tool chain. Maybe write the documentation in Markdown files, keep them in the GitHub repository, but otherwise treat them as just another source file, because then you get all sorts of good things for free, just like you do for code comments. But not everything should be in code comments. So like the README example, the overall system documentation, but on one small page. So this is kind of like, I don't know, doc ops or something. This is the right direction. This is, in many cases, more successful than trying to have a wiki or some kind of external documentation, because those products, they always get more complex. Just before I wrap up, I would like to mention that I do have a personal wish list of techniques that I'd like to try. So I'm going to mention them not because I have actually tried them, but because they sound good. I don't know if they actually work, but they probably do. The people who describe these seem to be pretty smart. The first one is architecture decision records. Lots of people have linked to Michael's blog post about this and tried it out. Now, this is a very clever idea that mirrors a couple of other clever kinds of documentation. The key idea for a particular kind of documentation, and this is about architecture, is write-only documentation. Documentation where you write a small piece of documentation and you never edit that. It's write-only, like an event store in an event sourcing architecture. And blogs are like this. Before blogging, there was this idea that maybe you should update your web pages. But if it's got a date on it, you don't have to, because it's just old. We'll just write a new blog post. And this is very liberating. A lot of the work is editing. So if you write only, you save a lot of time. You save complicated updates. Depending on your team rotation, how often you get new people, maybe this is less effort. Because when somebody joins the team, you just make them read everything from start to finish, and they've sort of loaded all of the decisions into memory. Another idea from blog post by Daniele Pochida is that there's more than one kind of documentation. And so a mistake that we might make is being confused about what kind of documentation we're writing. I would love to try this. This maybe helps. But maybe the best idea is to actually make the error messages good. I mean, that's quite radical. But maybe that would document the code and the user interface and make all sorts of wonderful things happen. But again, this is quite radical. I'm not sure anybody's ever tried this. But I would love to try that. So, to close, technical documentation is a kind of backup. Not having it is highly risky. You do need some technical documentation, but you don't need very much at all. You can keep it really small. If you keep it really small, you might actually be able to maintain it, because there won't be too much. And there are many new things to try. So it's a backup for your knowledge. You need it to be able to do maintenance. There are new approaches. I'm Peter Hilton. That's all I've got. If you want more, talk to MosaicWorks about training in maintainable code, or even documentation. Thank you very much.